Hello everyone, I am Pawan Pai. In this video, I am gonna explain about complex numbers. As we know, the complex numbers are the imaginary numbers which doesn't exist while we count in real world, but these complex numbers are required in the subject of electronics and physics and some engineering applications as well. So in this video I'm going to explain only basics of complex numbers and representation of complex numbers. So here, coming into complex numbers, we have we have any number of the form a plus ib, where I is equal to square root of -1. Generally, we represent complex number as a z1, z2, z3. In this way, we represent the complex numbers. Anyway, in we basic addition of complex numbers. Addition of complex numbers. If z1 is equal to a plus ib and z2 is equal to a minus a1 plus I times b1, now z1 plus z2 is equal to a plus a1 plus I times b plus b1. That is, we add the respective real and imaginary part. In complex numbers, we call this a as a real part of z1 and b as a real imaginary part of z1. And coming to multiplication, and also remember, this is z1 plus or minus z2, so both are applicable for complex numbers. Coming to multiplication now, z1 z2 is equal to, we multiply a plus ib, here we multiply them respectively, a1 minus b1 plus I times, like we are multiplying this particular factor here, I square is nothing but -1, therefore we will get, for finding the imaginary part, we will get a1b plus b1a. That is, we are multiplying the respective. These are just normal use of complex numbers. Division, I have a easier method later, so I won't do it in this way. Normally we will multiply the conjugate of denominator, but I'll use the other way normally when we use. Now we learn how to write a complex number in the form of exponent, and like any complex number can be represented as a e power ix. For that, let's learn some things about small things about polar form of a complex number. Here, if z is equal to a plus ib, then to find polar form, we are finding mod z, that is magnitude of the complex number, and angle theta. Let me explain angle theta later. Here mod z is nothing but square root of a square plus b square, and theta is equal to tan inverse of b by a. Just remember as y by x. It's because these complex numbers also perform similar to vectors. Like if we use I cap plus j cap, it even this has the same type kind of formula. So um, now we can write the polar form of the complex number, that is z equal to a plus I root of a square plus b square, that is mod z into cos theta plus I sin theta. I'll write this root of a square plus b square as model, as I've given the formula for that. This is like the polar form of a complex number. This polar form can be written in the form of exponential form also by Euler's. According to Euler, we get that cos theta plus I sin theta is equal to e power I theta. Now we get from above question that z is equal to mod z is nothing but root of a square plus b square and t e power I into tan inverse of b by a. Here we can write this is nothing but the transformation of a complex number in terms of exponential. This is a basic, and even we learn this in PU, but just this is an important thing we use. Now for division of complex number, if first z1 is equal to a plus ib and z2 is equal to a, I'll take c and d, c plus id, then let theta 1 and theta 2 be the argument of z1 and z2 respectively. 1 and theta 2. This theta is also called as argument of the complex number. This theta 1 and theta 2 are the argument, and the formula is same, tan inverse of b by a, and here tan inverse of d by c. And of z1 and z2. Now we can write z1 by z2 as by using previous formula. This is nothing but z1 is nothing but root of a square plus b square. Let argument be theta 1 e power I theta 1 by root of c square plus d square e power I theta 2. See, now argument I have given the formula already, so next we can simplify the using law of exponent. Now we get that z1 by z2 is nothing but, that is z2 is equal to root of a square plus b square by c square plus d square. Now by using law of exponent, e power I into theta 1 minus theta 2. See, now we have got it into a simple form. Now since we have the scientific calculators, we can use this formula directly and find the division of complex number with the less chance of being error. Also by this property, that is z is equal to mod z times cos theta plus I sin theta, that is the polar form of the complex number. We can derive many other relations like z power n. We need not multiply the complex number in n times. Instead we can write it in terms of like, now mod z as it is. Now cos theta plus I sin theta is e power I theta, therefore now raise it to power n. Now again by using law of exponent, we get that z power n is equal to mod of z power n into e power I times theta into n, because law of exponent a power b whole power c is equal to a power bc. That is the law of exponents. Now we can simplify this as root of a square plus b square power n into e power I times n theta. This is nothing but z power n is equal to a square plus b square power n by 2 into cos n theta plus I sin n theta. This is also called as De Moivre's rules, but we do not remember it. We can easily get it using law of exponents. I'll also give a small introduction of complex numbers in calculus also. For example, let me take y as the function of x, that is y of x is equal to um, e power ix plus sin ix square. Now if you want to differentiate this, it's just, this is too complicated for understanding. I'll just take e power ix example. Also, for differentiating this, we must take I as a constant here. Therefore dy by dx is nothing but I is a constant, so first write e power ix as it is, then chain rule, that is differentiation of ix is only I is a constant we are taking, therefore I e power ix. If you want, you can verify it by Euler's form also. I took y is equal to e power ix, right? So I'll take y is equal to cos x plus I sin x, that is really equal to e power ix according to Euler. Now but I'll just verify and check. See, dy by dx is nothing but cos x is nothing but minus sin x, derivative of cos x is minus sin x, plus derivative of sin x is nothing but cos x plus I times cos x. Now take I common on both sides, right? Now when I take I common on both sides, the time I get dy by dx is nothing but I times cos x, that minus 1 by I times sin x. Now we'll multiply and divide sin x by I. Here it's I, multiply and divide by I. So now we get that dy by dx is nothing but cos x. This I sin x I'll take as it is, and I into I is minus 1, so I'll take minus I here and it will become plus. Therefore cos x plus I sin x, which is nothing but e power ix according to Euler, which is equal to e power ix into Euler, that is I times e power ix. See, by using both results we get the same answer as derivatives. And here comes the end of the video. I hope you have understood some important points about complex numbers, and these are highly applied, especially in engineering. You have like Laplace transform, Fourier series, and also in electrical engineering we have circuits, the LRC. These are very highly applied, so it's very important to know basics of these complex numbers. Hope you liked it. Thank you.